चलिए अब start करें. अच्छा, if you have any question, ठीक है, just ask. Okay, whenever you don't understand anything. So starting with entropy, the first thing about entropy is okay, it's a measure of the disorder of a system. Okay, that's the first basic thing. Okay, entropy is the symbol for entropy is S. If there's a not on top of it, that's standard entropy. Okay, so not just indicates that it's being measured under standard conditions. Okay. Now entropy is a measure. I mean, that's the literal definition of this. It's a measure of the disorder of a system. So if in any paper they ask you about it, that's the definition. So it's a measure of the disorder of a system. अब इसमें ये कि हाँ जी
सर ये एनर्जेटिक्स का लाइक थोड़ा ये एनर्जेटिक्स के अंदर ही आता है, लाइक सब टॉपिक है या मतलब ये अलग से?
मेरे ख्याल से सब टॉपिक ही है. But entropy is not a separate topic. It is part of energetics. वो confirm कर लेंगे syllabus खोल के, लेकिन definitely part of energetics. Actually, the first thing is it's a measure of a disorder of the system. ठीक है, तो I explained last time that there's if there's a very neat and tidy room, ठीक है, and on the other hand you've got a very messy room. ठीक है, a very messy and untidy room. So one is a high entropy state, the other one is a low entropy state. So there are two states of the same thing. One of the state is low entropy, the other one is high entropy. Mr. Consi, which one is high entropy, which one is low entropy?
So neat and tidy.
वो क्या high entropy है?
Sir, high entropy होगी.
Low entropy है. Low disorder. अच्छा, entropy, whenever entropy comes to your mind, it just means disorder. So it's low disorder, right? So that means it's low entropy. Clear? And this state over here is a high entropy state. That means it's a highly disordered state. ठीक है, तो
सर वैसे डिसऑर्डर का मतलब ये होता है ना कि मतलब एटम्स के बीच में लाइक डिस्टेंस मतलब ज्यादा हो या कम हो, उसके ऊपर
हाँ,
डिपेंड करता है.
वो मैं अभी एक्सप्लेन करता हूँ. डिसऑर्डर अभी तो लिटरली हम क्वालिटेटिवली स्पीकिंग ना, what is disorder? ठीक है, we just know कि if something is disordered or something is ordered. ठीक है, मतलब for example वो or diagrams भी I can attach more diagrams to this कि high entropy, low entropy. The first thing is you have to make this clear कि what's a high entropy state, what's a low entropy state. तो ये actually बड़ा अच्छा example है. ठीक है, so if I just copy this image, बल्कि इस image में दोनों को अलग-अलग कर लेते हैं. ठीक है, so I've got a low entropy state. ठीक है, so that's kind of a low entropy state, and on the other hand I've got a high entropy state as well. ठीक है, messy state. So abhi we just talking about qualitatively. We're not defining entropy. We're not measuring entropy. ठीक है, so we're just trying to figure out कि high entropy वैसे क्या है, generally what is high entropy. So this is clearly a high entropy state. ठीक है, and the other one is a low entropy state. तो ये clear है ना? तो दिमाग में पहले बिठा लो, entropy is disorder. ठीक है, entropy just means disorder. Now the second, Rizwan, clear है?
Yes.
So now the second thing is when you're talking about disorder, the same state can change as well. Okay? A high entropy state could go into a low entropy state and vice versa. Okay? That's known as a change of disorder. So you can go from low entropy to high entropy. So that means you're gaining entropy. Okay? That's a gain of disorder. तो आपका जो room होता है ना, that over time what happens to it, it becomes more disordered. ठीक है, कि सुबह अगर साफ किया तो शाम तक it's going to be very very disordered. The marble balls over here, if the marble pieces over here, if you keep it like this and you start shaking it, it's going to gain disorder. ठीक है, so gain of entropy, that is known as delta S. That delta stands for change. So there's entropy that's changing, and that is delta S positive. ठीक है, increase हो रही है, entropy is increasing in this case. ठीक है, vice versa, if you're going back, so that means you're losing, there's a loss of entropy. ठीक है, so you lose entropy. And that is delta S negative. ठीक है, so you're constantly losing entropy. So is this clear? Delta S positive, delta S negative. Is this clear?
Yes, sir.
ठीक है, तो मुझे quickly बताओ कि I have a car and after 10 years, what happens to it? Delta S positive or delta S negative? Let's say I buy a new car and after 10 years, it becomes very broken down. And so is that delta S positive or delta S negative?
So positive.
Positive, there's a gain of disorder, right? ठीक है, delta S positive. So you can see delta S positive, delta S negative all around you. ठीक है, कि आपके घर में ना, there's a gardener that's coming to your house and he cuts all the trees and trims all the bushes, etc. So what is that? Delta S negative or positive?
Negative.
Negative है, क्योंकि you're losing disorder. ठीक है, you're becoming more ordered. So so basically idea, delta S positive, delta S negative, keep that in mind. And then we will eventually going to apply it to chemical reactions as well. So अच्छा, इनमें से which one is easy, delta S positive or delta S negative? Getting into a disordered state, is that easy, or going back into an ordered state, is that easy?
Easier to be more disordered?
ठीक है, it's a lot easier to be more disordered. ठीक है, that's easy because you don't even have to like अपना room खराब करने के लिए, if you want to make your room, turn your room messy, you don't particularly do anything. I mean, even if you don't do anything, it's just going to automatically become disordered. So this one, delta S positive, remember, is very or relatively very easy to do. Vice versa, delta S negative, it's harder to do. Okay, so that's like a universal law. ये दूसरा difficult है, sorry. This one is difficult. So that's going to be more difficult. So that's like a universal law. It's there's a reason for that, and the reason is the number of disordered states are a lot. If you shake a jar like this, there are infinite possible ways the marbles could arrange themselves in a very disordered way. So the amount of disordered states are like infinite. But the amount of ordered states, that's just very few. Like if you want to arrange the marble in a very neat and ordered way, तो क्या कितनी states होंगी? That's just one or two states, right? So like if you want to keep your room neat and tidy, there's just a few number of states in which you can keep your room neat and tidy, right? But if you want to make your room messy, there are like infinite possible ways that you can actually make your room messy. Okay? So the high entropy state is a high probability state. There's more probability, you got more events. Okay, there's more events, almost infinite events of high entropy states. And it's got a very, very high probability. Okay, so there are infinite possible ways in which the marbles can be arranged in a disordered way. And there are very few events. So there are lesser events, so it's got a very low probability. और इनके बीच में difference is so huge, probability wise, like you've got infinite disordered events and you've got just one event in which this is going to be ordered, right? So the probability is almost close to 0. And over here, the probability is almost close to, it's almost close to 1. Yani 100% probability, ठीक है? Yani if you shake a jar that has marbles in it, you probably end up with a disordered state because you got more events. Is that clear? You clear?
Yes, sir.
Achha, so that makes high entropy states very stable as well. And that makes low entropy states very unstable. कि इसको जरा सा भी shake करोगे, you'll end up with a high entropy state. You shake it, you're still going to end up with a high entropy state. So just one second. So the thing is, a high entropy state maintains itself. A low entropy state does not maintain itself. It's very unstable. So this thing is unstable. So things, or the universe does not like low entropy state. So this one is unstable. It changes very quickly into a high entropy state. And this other one is the high entropy state is going to be it's going to be very, very stable. Okay, it's going to be very stable and it's going to try and maintain itself. Okay, no amount of shaking, it's always going to result in a high entropy state. So, or universe में ना, this is happening everywhere. ठीक है, अगर आप अपना, let's say there's an abandoned house, eventually it's going to reach a high entropy state. It's going to start breaking down. ठीक है, that nature के अंदर there's one thing that actually goes against this, and that is living organisms. They actually do the opposite. ठीक है, if I'm the living organism, then I'm actually doing the exact opposite. I'm taking all random stuff from nature, and what I'm doing is I'm organizing them into different cells that work in a very specified ordered way. So living organisms, they actually do the opposite. So wherever you see living organisms, the high entropy state turns into a nature by itself. ठीक है, अगर आप जंगल में जाओगे ना, that's a high entropy state. But wherever you see living organisms, you actually see low entropy states. This is what we do. I mean, living organisms, they're constantly, what they're trying to do is they're moving high entropy state to a low entropy state. ठीक है, आपका जो cities होंगे ना, they're very ordered, right? But as soon as you go into a mountain, that's very disordered, right? So humans do this. Lekin what happens is so it's not, we're not actually breaking the law. ये जो law भी हमने पढ़ा है कि high entropy states are more stable. What we do is we create, overall we actually increase disorder. ठीक है, कि हम city को तो बड़ा वो कर लेते हैं, order कर लेते हैं, लेकिन around it we produce a lot of garbage, we produce a lot of pollutants. So the overall effect is that we actually increase disorder. तो इसलिए वो living organisms जो है ना, localized तौर पे ना, in a very localized area, they're actually increasing disorder, but in other parts they're actually increasing disorder. तो हम actually पूरे planet को disordered कर दिया हमने, ठीक है, because of human activity, right? So we create this very tiny pocket of order, but we create a lot of mess doing that. So लेकिन living organisms constantly try to do the opposite, ठीक है. Anyway, so let's apply this to chemistry. And chemistry, we just need to, first thing is we need to figure out, pehla question aayega, that's going to be delta S positive, delta S negative. You need to figure out whether delta S is positive or delta S is negative. So the first thing is, how do you figure out in a chemical reaction कि entropy is increasing or decreasing in that chemical reaction? So the first thing about this is you've got changes of state. So if you have solid and you've got a liquid and you've got gas. अच्छा, so which state is ordered and which state is disordered? यहाँ से picture भी ले लेते हैं एक second. Solid, gas. तो ये कर लेते हैं. अच्छा, so this one is the first one, ठीक है? So what's going on over here? If you so forget add energy, remove energy, ठीक है? That's, we're not talking about energy. What's happening to delta S? Delta S is becoming positive or negative in this case? More disordered or less disordered?
Positive.
More disordered.
ठीक है, so delta S is over here becoming positive, and over here it's also becoming positive. And if you go back, so that's to reverse जो है ना, that's going to be negative, ठीक है? So if you go from gas to liquid and liquid to solid, so that will be delta S negative. ठीक है, you're going to become more ordered or less disordered, ठीक है? So first thing, solid to liquid to gas, whenever you see that happening in chemical reactions, अच्छा, इसके अंदर ना, also remember this thing that there's delta S positive over here, that's small. It's not very large. It's not a very large delta S positive. ये जो आपका solid to liquid है ना, I mean, look at the picture over here. It's not that disordered, ठीक है? It's just slightly more disordered. But when you move towards from liquid to gas, that's a huge gain of disorder, ठीक है? So delta S positive over here, that's going to be a very, very large gain in disorder. This delta S positive is going to be very large. ये point clear?
Yes.
ठीक है, so that's large. बाकी clear है ना? अच्छा, और फिर इसमें ना वो है कि अच्छा, इसमें yes no लिख दिया करो यहाँ पे चार्ट के अंदर. अच्छा, so the other thing is कि so they might ask you to actually plot this, like let's talk about water, ठीक है? How would you make a graph of water turning into, उसका ना S entropy plot करनी है, ठीक है? So we need to figure out the entropy, एक side पे entropy है S, and on the other side you've got temperature, and let's say it's in centigrade, and you've got 0 degrees centigrade over here, and you've got 100 degrees centigrade over here. Achha, explain to me what's what will the graph actually look like? It's before zero kya hoga? Entropy, will it be for water? Will it be high or low? Before 0 degree centigrade is part.
Sir,
हाँ.
sir, entropy मतलब सीधा मतलब straight line ऊपर की तरफ जानी चाहिए ना, क्योंकि वो directly proportional है मतलब.
ये किसने कहा मैं directly proportional है? मैंने तो नहीं कहा. अभी तो खाली वैसे guess करो ना. चलो ये बताओ मुझे, वैसे guess करो. Water below zero क्या होता है? Solid ice. It's solid ice, right? So let's say there's water at minus 50 degrees centigrade. And then the same water, again, it's going to be ice, and it's at minus 10 degrees centigrade. So मुझे explain करो, is there going to be a huge change in disorder between the two states?
No, sir, कोई ज़्यादा disorder नहीं है.
Well, it's exactly the same. Solid, this is also solid. I mean, if I show you ice at minus 50 and I show you ice at minus 10, तो आपको तो कोई difference नहीं पता. You'll actually see the exact same thing, right? Is that clear?
Yes, sir.
So the point is okay, over here there's not a lot of change in disorder. It's very very slight. ठीक है, तो 0 degree centigrade तक ना the entropy is barely going to change up till this. ये थोड़ा ज्यादा steep कर दिया, but it's ये ठीक है. अच्छा, it's barely changing. ठीक है, hardly any change happens. It's very low entropy, right? Low entropy, and it's very very disordered. Is this clear? ये clear है?
Yes.
So then what happens at 0 degree centigrade?
Entropy increases.
Okay, and all of a sudden it increases, right? Because all of a sudden the molecules they become liquid. So over here, at 0 degree centigrade, the molecule becomes a liquid. And when it becomes liquid, so there's this sudden jump that's going to happen. And all of that jump is going to happen at 0 degree centigrade, right? And what happens if the liquid water is at 10 degrees centigrade, then let's say it's at 80 degrees centigrade. Is there a massive change in disorder or not?
No.
Okay, because if I show you two glasses of water, one is at 10 degrees centigrade, the other one is at 80 degrees centigrade, you won't be able to figure out any change in disorder. Like it's going to, I mean, they're going to look like exactly the same glass of water, right? So there's going to be some very slight difference or a slight increase. I'll explain why that would be the case, but just very, very slight. So then what happens at 100?
Steep increase again.
So again, there's going to be a steep, and there's going to be a very large increase this time. I just told you that this change in disorder, that's like huge. Okay? So there's going to be a very, very large increase in disorder. Okay, so there's going to be a very large increase in disorder because now it's turned into steam. Achha, now tell me about this one. Okay, if you have steam at let's say 110 degrees centigrade, and then you have steam at let's say 200 degrees centigrade, will there be a change in disorder? Like, will you see a change in disorder in steam at 110 and the same steam at 200?
Yes.
So ज़्यादा change.
There's going to be a very large change because you see steam molecules, gases can expand. Okay, so when gases expand, the amount of disorder is going to increase. Gases, when you heat them, so gases can, what happens is that it's going to increase. So for gases, it's going to apply because steam at 200 degrees centigrade, steam at 2000 degrees centigrade, the amount of disorder is going to be drastically different. Okay? Steam at 110 degrees centigrade, that will not have that much disorder. Steam at 10,000 degrees centigrade, it's going to have a lot of disorder, or it's going to create a lot of disorder. Okay? So is that clear? Gases can expand, and when they expand, liquids can't expand. So when you see a glass of water at 10 degrees centigrade or a glass of water at 80 degrees centigrade, you kind of see the same thing. Solids don't expand as well. Okay, ice at -10, ice at -50, ice at -200, you kind of see the same thing. But when you look at steam, you don't see the same thing. Steam there's going to be a huge difference between steam at 110 and steam at 1000. Is this point clear? There's going to be a lot more disorder in steam when it's at a higher temperature. Is that clear?
Yes.
So, अच्छा इसको फिर लिख भी लेते हैं कि I mean, the steep rise is clear, but for steam, remember this, that gases expand. When heated. hence their entropy increases. Okay, we're not going to call it standard entropy because we're not doing it under standard conditions. So S increases as temperature increases. So S keeps on increasing as temperature increases. अच्छा यहाँ पे start में ना it's going to be very little change, almost negligible. तो यहाँ पे मैं add कर दूं कि so this one. So very little very little change. More energy, there's obviously more kinetic energy. But arrangement kind of remains the same. So because of more kinetic energy, the arrangement is very slightly different, as particles are held together by strong intermolecular forces. So the strong attractive forces, they don't allow the particles to get disordered. So particles are held together by strong attractive forces. So that's your graph for water at least. Okay, you can make a solid to liquid to gas. You can make another graph for any other substance except their boiling points and melting points are going to be different. Okay. So moving on, to you hopefully clear. That's the first thing. In a chemical reaction, you see solid liquid to gas. There's an increase in disorder. Second point is, what if they're all gases in a chemical reaction, right? So second point is, delta S is positive if gas moles increase because gases have more disorder. So if moles of gas in a reaction increase, so for example, you've got so you've got this reaction, which is you see calcium carbonate reacting with HCl and it produces what? It produces calcium chloride and water and carbon dioxide. So this was solid low entropy. This was aqueous, slightly higher entropy. This one was also aqueous, slightly higher entropy. This one is a liquid, and then you have a gas all of a sudden, and that's very high entropy. So you've got 0 moles of gas on the left side. और आपका जो right side है, you've got 1 mole of gas. So that means in this case, delta S is going to be positive. Because your moles of gas, they ended up increasing. Okay, so your moles of gas, they ended up increasing and delta S is going to be positive. Or vice versa, or opposite be true. Okay, so the opposite is also going to be, it's also going to be true that the moles of gas, if they decrease in a reaction, So for example, if I have another reaction in which I've got N2 and 3H2 and they react together to form ammonia. Is case where what's happening is okay, my moles of gas are decreasing. So I had all of these were gases. So all of these were gases, and I had 4 moles of gas. And on the other side, I now have 2 moles of gas. So that means delta S is negative. Disorder is, as your disorder is decreasing. Okay, is this clear?
Yes.
ठीक है ये वो मतलब कोक वाला एग्जांपल इस पे अप्लाई होता है कि like if you pour coke, all of a sudden there's a lot of disorder, there's a lot of gas bubbles being produced and the coke might spill. ठीक है, so वो carbon dioxide gets produced, right? So when you pour Pepsi or Coke in a glass of water, उसके the carbonate in the water, it turns into carbon dioxide. So something similar to that happens. So delta S is positive, more disorder gets created. I said, then number 3, what else in chemical reactions? What if a chemical reaction doesn't even have gases, right? So if no gas is present, so if you don't see any gas being present, then the first thing is, okay, are your liquid and aqueous moles or the number of particles in liquid and aqueous state, are they increasing? So if your if solid particles are turning into more particles of liquid and aqueous kind of have similar disorder. Then that is delta S positive. Okay, so if no gas is present, then you look for liquid and aqueous state. If you just now, for example, if I've got this reaction, I've got NaCl solid, and that NaCl solid, it turns into Na+1 aqueous and Cl-1 aqueous. So that's dissolving, dissociating. So delta S is going to be positive in this case. As a second, another thing is if you have the same state, then you just look for the number of particles. Are they increasing or are they decreasing? If you have exactly the same state. So if state, let's do another one. I've got a reaction where I've got Ag+1. It likes to gain electrons. So I've got Fe2+. The Ag+1 gains electrons and becomes Ag solid. And the Fe2+ loses electrons, becomes Fe3+. So this is aqueous, this is aqueous. This is also aqueous. Now this one is a solid. So what's happening is that the number of aqueous particles are decreasing. So that is delta S negative. Okay, so that means it's becoming more ordered. It's turning into a solid, so that's less disorder. So delta S in this case is negative, it's decreasing. These are examples clear?
Yes.
So, and sometimes what you'll also have is you'll have sometimes what will happen is you'll have exactly the same state. So if all the states are the same, so number 4 is if everyone has the same state and there is no change in state, then you just count the number of particles. If less particles turn into more particles, then there's an increase in entropy, and vice versa. Okay? So they turn into more particles. That is going to be called delta S being positive. You've got some ligand exchange reactions which you don't know of at the moment, but I'll just show you one K. It's going to be something like this, that there is, let's say there's Cu with water, 6 of them. So let's think of this as a particle, right? And you add a molecule of, so you add 3 molecules of a substance which is a diamine, that's NH2, CH2, CH2, and then you've got NH2. Everything is happening in aqueous state. You add this substance and a reversible, let's say not a reversible reaction, let's say it's a one-sided reaction. It happens. And the water molecules, they get knocked out, and instead these 3 diamine molecules, they take its place. And NH2, and 3 of them, they join up and they displace the water molecules that were with copper. And 6 water molecules, they get displaced. ऐसे reaction आगे जाके पढ़ोगे, अभी फिलहाल बस इसको simply समझो कि what's happening is that copper was attached to 6 water molecules. This molecule came in, it knocked out all the water molecules, took its place. 6 of the water molecules got knocked out. Now, all of this is happening in a solution in aqueous state. So the state is the same, but your number of particles are increasing. You had 4 particles initially. In total, you had reactants where you had 4 particles, like 1 of this, and you had 3 molecules of this. So you had 4 particles. But now what you have is you've got 7 particles. So there's an increase in disorder, and that's delta S. So that one is delta S positive. The number of particles have increased. ठीक है? ये reaction कहाँ से है, क्यों हुआ है, उसको भी छोड़ दो. Just figure out कि the number of particles are increasing in this reaction. So the delta S happens to be positive. ठीक है? तो ये सारा clear है? Is this clear?
Yes.
और इसमें important thing is just remember कि gases, they have a lot more disordered compared to solids and liquids. Okay, when something changes from solid to aqueous or liquid to aqueous or aqueous to liquid, that's not a big increase. But when something changes into a gas, that's a huge increase. So चलो ठीक है, कल continue करते हैं. We'll continue with this tomorrow, and उसके questions भी करते हैं past paper के, and then we'll do the mathematical stuff. ठीक है? हाँ जी.
सर वो जो अपने जो कोबाल्ट के कलर्स दिखाए थे ना, ये मतलब वो ट्रांजिशन के वाले बात, सर वो मार्क्स स्कीम के अंदर पता नहीं कोई चेंज आया या शायद मार्क्स स्कीम के अंदर गलत लिखा, वो ईयर भी याद से नहीं आ रहा, लेकिन वो प्रेसिपिटेट का वो गलत रंग बता रहे थे, वो जो
ब्लू तो नहीं बता रहा था
सर, वो पता नहीं येलो या ब्राउन का मेंशन कर रहा था सर, उसमें शायद कोई इसने चेंज किया. नहीं,
कोबाल्ट के ये कलर्स है ना, मैं बताता हूँ फिर से, और यही है, इसके अलावा कोई नहीं है. ठीक है, एक से मैं पहले बंद कर लूं.